Hello, algebra students, and welcome to Chapter 2. This is a note-taking template that you should have in front of you. I should have given it to you in class. If you don't have it, you can print a blank one on my website. I'll just call it 3-column notes. You can print it off, and you'll just have to write a few things on there that aren't on your paper right now. But if you picked mine up from class, you should have some of this stuff on your page, hopefully. One thing you'll need to begin with is putting down the topic and objective. As we begin Chapter 2, we're going to hit 2 sections at once. And this is based on some things you should be familiar with, so we're going to go through that fast, and then a few things that might be new for you. So if you have not written down the objective, please do. We'll be learning how to solve two-step equations and equations with fraction coefficients. So get that down, and also be sure to fill out your name, hour, and date, as you should have your notes organized by date in your binder. So if you'd get that filled out, and we will get started on things. I went ahead and labeled some of the information for you. What we have here is we have a 3-column notes, where this first column right here, we want to put as little information as possible, just kind of the idea of what we're taking a note on, the main idea. In the middle column, we'll use that to do examples, math examples, and then over on the far right, we will use that to describe and explain what it is that you've worked there in the middle. Many college math professors think that this is the best way to organize math notes when you're just taking notes by hand. So I will use it frequently, and I agree that it is one of the best that we use. So the first word here that we're going to talk about is this word coefficient. Coefficient is how you say that. So let me show you what that is. If you don't remember, write the word term right here with a line under it. And over here, write the word coefficient. Just to make sure that we are all on the same page. Well, a term is basically anything that it could be a number, or it could be a number times a variable. For example, 5x is a term. In this term, the coefficient of that is 5. That's the number in front of the x. Let's try one with a fraction. You could have, say, 3/4 y. The coefficient of 3/4 y, it's the 3/4. What if we have a negative number, like -2/3 x? The coefficient of that, we keep the sign, -2/3 is the coefficient. So what you'll notice, obviously, is that it's this number that's being multiplied by the variable. That's a coefficient. So we'll explain that over here. What we're doing here is we're saying that a coefficient is a number, and you can abbreviate. I encourage you actually to abbreviate. A number multiplied by a variable. Okay, the coefficient tells you how many, in this case, how many x's you have. You have 5x. You have x 5 times. That's what a coefficient does. All right, once that's down, what I would like you to do is draw a barrier line. I usually like to use a dotted line. You can do a solid line. You can fill in the whole line. But what we are doing here is we are separating our notes. So we're done with coefficient. We're going to go down now and talk about this word reciprocal. Okay, and for reciprocal, we're going to do something kind of similar. I'm going to extend my page down a little bit here because I'm going to need a little bit of room to write. A reciprocal, in this first column, I'm just going to put a number sign. Now that means number, not hashtag. That's what that originally meant before hashtags were around. And then over here, write the word reciprocal, so we can make sure we know what a reciprocal is. If I have a number such as, say, 2/3, the reciprocal of 2/3, I'll just show you what it is. If you recall, you flip the number upside down. It's 3/2. That's reciprocal. It's that simple, really. There's a math purpose behind this. I'll show you in a moment. Say we have the number -4/5. The reciprocal of -4/5. And we keep the sign. Okay, we keep the sign, but we would still flip it to -5/4. Or let's say I have a whole number such as 9, my favorite number. What would 9 be flipped upside down? Did you say 1 over 9? If you did, you're right. That's what it is, 1 over 9. Now, so you can remember it by flipping the number. That's probably the way you'll remember it, and that's fine. But what you do need to understand is the true math definition. That's supposed to be a little star right there. The true math definition of a reciprocal is the product, it means multiply, of two numbers equals 1. The product of two numbers equals 1. Now, as you're taking notes here, you may space it out a little longer than I do because I'm limited with space with the size of my ink here, because you want to make sure you get all the information by reciprocal before you get to that example at the bottom of the page. The product of two numbers equals 1. Well, let's just take the first one I did there to show you what I'm talking about here. If I take 2/3, which was here, and the reciprocal and multiply them together, well, these two numbers are reciprocals. Watch what happens when I multiply. 2 times 3 is 6. 3 times 2 is 6. 6 over 6 is positive 1. That happens every time. It has to end up being positive 1. If I did it with this example here, negative 4/5 and negative 5/4, a negative times a negative would make that positive. You would end up with 20 over 20, which would be 1. So that is always the case when you multiply reciprocals. That's the true definition. The answer is 1. Now that's very important for us as we move into solving equations, which we're going to begin doing at the bottom of this note page that you have in front of you. Now what you'll also notice is you're still on the first page, but again, because of the size of my pages, I sometimes have to go to a new page. You just stay where you were. You should have a barrier right above that you just drew from my previous slide. And now we have this example right here. This is actually from page 84 in your book. You can see more examples or read about this if you'd like to on your own there. So we've written down this problem. What we're going to do now is the directions would be to solve this. To solve for x, 4/5 times x equals 48. So what we want, only in this area here do we want the question written. In this area in the middle, we're actually going to work it out. So what you will need to do first is recopy and make sure you have a few lines here to do a little bit of work. You should have just enough space at the bottom, I hope. 4/5 x equals 28. So recopy the question there. Recopy the question. Now, before we get started, before we write stuff over here, when we solve an equation, the goal is to get 1x. Okay, that's the name of the game. 1x. 1x. When you solve equations, you get down to 1x, you win. All right, that's the whole name. Get 1x. So all this year, when we get in these wild, crazy equations we're solving for, that's our game. Get it down. What is the value of 1x, or whatever the variable is? So if I have 4/5 times x, if you don't recall how to do that, this is how we would like you to do this. If I'm trying to get 1x, well, remember this previous slide here when we talked about reciprocal? If you multiply two numbers, that's right above you, above your notes there where you are. If you multiply two numbers that are reciprocals, you get 1x. That's the whole game. So if I have a fraction times a variable and I multiply the reciprocal, you need to write this down just like this. When you do this step, I will allow you to do this on the original line of the question in your work. Okay, we have to do this to both sides. Remember, the golden rule of math when you're solving equations is do to one side as you do to the other. That keeps my scale balanced. And I can manipulate the question however I want to get 1x. So when I multiply 5/4, I'm looking at the left side, times, when I go 5/4 times 4/5, basically these two 5's cancel out, these two 4's cancel out, and you're left with basically the number 1. I'm going to do it silly here. I don't know if you'll have room to do this, but that is the number 1. You don't have to draw this red 1 here. I saw a college professor do this once. I thought it was funny. That's the number 1 right there. 20 over 20, that's 1x. So this became, let me get this out of the way here because like I said, you probably don't have space to do that part. This became 1x. 20 over 20. So what you have to do over here is you have to simplify this side right here and multiply this out. 4 goes into 28 7 times. 7 times 5 is 35. So what I did is I multiplied reciprocal both sides. All right, I've hit my max time here. I'm going to stop this video, and when I come back, I'm going to show you how to check this problem, and we will go from there.